Good morning, everyone. So, last class we were dealing with chemical bonding, right? So, we started with bonding. What we learned over here? In chemical bonding, we started with why any element undergoes reaction, right? The first thing that we understood yesterday was that why two elements undergo reaction, why they go for reaction to gain stability. They want to gain stability by losing their potential energy, right? So, first reason of chemical reaction was to gain stability. And what they do for gaining stability? They undergo reaction. They form new bonds. Whenever there will be attraction, energy will decrease, potential energy will decrease, stability will increase. Now, while bonding, what they tried, all the elements tried to fulfill the octet rule, right? This was our first factor that we understood. What is octet rule and what is duet rule? Octet and duet rule said that any element undergoes bonding to form a bond, they form a bond to have 8 electrons in their outermost orbit. क्या चाहिए था उनको? They needed to have 8 electrons in their outermost orbit. They tried to achieve the electronic configuration of noble gas, right? So octet rule, that means they want to achieve the configuration of noble gases, right? So they tried to achieve the configuration of noble gases. That's why they underwent bonding, and for this we understood that there are 3 types of bond. What are they? Covalent bond and electrovalent bond and coordinate bond. So 3 types of bonds are there: covalent, electrovalent, coordinate. What was covalent? It was 50% partnership. It was our investment model as per our theory that we understood yesterday. What was the theory yesterday? Ki electron is money and reaction is business. So on that basis we define that covalent is our 50-50% partnership, electrovalent is investment model, and coordinate bond is Krishna Sudama friendship. These were 3 different models that we had to study. Okay, now a little bit in depth we go for them. So what was covalent? Covalent bond was equal sharing of electron. Equal sharing of electron, right? So A and B both will put 1 electron and they will form a bond. Now this is known as bond pair. In a covalent bond, we have 2 types of electron. First one is 1 electron each they have shared and they are forming a bond. This is known as bond pair, right? Another thing that we can have, ki A and B have some electron over here and some electron is kept like this. This will be lone pair. So what is bond pair and lone pair? A pair of electron that is shared between 2 elements, that is our bond pair, and any pair of electron that is along with the only 1 element, that is our lone pair. Okay, for example, what we had seen, ammonia. So ammonia was written something like this, where this will represent our bond pair, lone pair, and these will represent our bond pair. So in ammonia we have 3 bond pair and 1 lone pair. Each pair of electron is of 2 electrons, lone pair or bond pair, right? Okay, similarly if I have another example like XeF4, here I have 2 lone pair and 4 bond pair. Okay, so we have 2 lone pair, 4 bond pair. Got it, everyone? Now, if I look at this molecule Xe and F4, the first thing, the basics that we started with, that any element want to achieve the electronic configuration of noble gases. So in ammonia, nitrogen was trying to have the configuration of nearest noble gas, that is neon, and hydrogen tried to have electronic configuration of helium. But now our main problem is here that the noble gas itself forms a compound. Xe, that is a noble gas, that forms a compound. So the first step that we took, what was that? Octet rule. What was that? To achieve 8 electron, to have the electronic configuration of noble gases. It failed. Why it failed? Later on, it is found that noble gases also forms compound, that means they also undergo bonding. So noble gases or inert element that we call as inert element, they are also not completely stable. They are also forming compound. For example, XeF6, XeO2F2, XeO4, H4XeO6. There are few compounds formed by xenon. That means noble gases, a theory on which we were based upon, was not completely correct. Right now, it was not completely correct. Because if noble gas is so stable, they should not undergo bonding, they should not form a compound, they should not undergo chemical reaction. Right now? So this octet rule failed. Why? Because noble gases was found to form compound. Besides, there were some compound. Second thing that was the problem for this octet rule, besides some compounds, the element was found to have more than 8 electrons. More than 8 electrons. In some compound, what it was found? That element, central element, has more than 8 electrons. For example, PCl5. PCl5 has 5 bonds of Cl. Now each bond is representing 2 electrons, right now? So in total, how many electrons we have? In phosphorus, I have 10 electrons. In SF6, how many bonds we have? 6 bonds. Each bond is representing 2 electrons. How many electrons we have here? The sulfur is surrounded by 12 electrons. Phosphorus is surrounded by 10 electrons. Right? So they are violating octet rule. They are going beyond 8 electrons. Any noble gas has 8 electrons in their outermost orbit. And this was the basis of chemical reaction, chemical bonding. The first problem was that noble gas itself underwent chemical bonding. They went to form some compound, and some elements had electron more than 8. Let's have few more examples. For example, SF4. In SF4, we will have 1 lone pair and 4 bond. Each bond is representing 2 electrons. So here sulfur has 10 electrons. Right now, SF4, we have 10 electrons into it. Next compound, for example, XeF6. Here Xe has 1 lone pair and 6 fluorine. So how many electrons it has? 6 bond pairs and 6 bond pair and 1 lone pair. In total 14 electrons are there. Right now? In fact, XeF8 is also formed where we have 16 electrons. TeF8 minus 2 is formed. All of them will have more than 8 electrons in their outermost orbit. So, the first problem that was noble gas undergoing chemical reaction, and the second problem was that few elements had, they were stable element compounds had element with more than 8 electron, and such compounds are known as superoctet. Such compounds are known as superoctet or hyperoctet. They are known as superoctet or hyperoctet. Good enough? Now, next thing, few compounds, another compounds were found, are found to have electron less than 8. Few compounds had more than 8, few compounds have less than 8, and they are known as hypooctet. For example, if I look at BCl3, in BCl3 boron forms 3 bond. Now if you look at the electronic configuration of boron is 1s2, 2s2, 2p1. Here we have 3 electron in the outermost orbit, and all these 3 electron undergo bonding. So after bonding, how many electrons they have? Boron here has just 6 electrons, right now. So here boron is hypooctet. Let's have one more example, BeF2. Now if you look at BeF2 or BeCl2, so it has only 2 bonds. Beryllium is 1s2, 2s2, it has 2 valence electron, both used for bonding. Now beryllium will have 4 electron in their outermost orbit, right? So here these two elements, these two compounds that we have seen, they are hypooctet. So now can we revise the octet rule? Yes, we can now revise the octet rule. What we can revise? We have to again to restudy it. And what we find, that all the elements are not following octet rule in their compounds. Right now, some of them have below octet, some of them have more than octet, and last, key noble gases are also not, you can say, ultimate stable. Okay, they are more stable than other elements, they are less reactive than other elements, but they also undergo bonding to gain more stability. Right now? So, what will be the summary for octet rule? We know that octet rule failed. Octet rule fails here. But can we go for few compounds, few elements that will follow octet rule? Yes, we have element from hydrogen to, you can say, Mg. They are hardcore followers of octet rule. Followers of octet rule. They always follow octet. From hydrogen till magnesium. You can also go till silicon, but they can also break it sometimes. So we will get to magnesium. Another thing, if you go for ionic compound, generally follows octet rule. Ionic compounds will follow octet rule. When there is loss or gain of electron, then they will follow octet rule. So now octet rule is confined to a very small region. What we say, element from hydrogen till magnesium will always follow octet rule. And second thing what we say, ionic compounds will generally follow octet rule. Okay, so octet rule failed here, and we have just 2 or 3 points at where octet rule is followed. So this was an overview of octet rule and chemical bonding, first theory of chemical bonding. So after the failure of octet rule, then we started studying in a different way, and we came up with 2 different theory that is in our syllabus in class 11, that is valence bond theory and molecular orbital theory. This we will study in class 11. Right now we are going to study next thing, sigma bond and pi bond. Now bonding takes place, we know. We can have ionic bond, we can have covalent bond. In covalent bond we have 2 type of thing. We have lone pair, we have bond pair. Lone pair are the electrons present on the element, and bond pairs are the pair of electron between 2 elements. Right? Now bond pairs are of 2 types. Bond pairs are of 2 types, that is sigma bond and pi bond. A little bit we will study about sigma bond and pi bond. Okay, what it says, the bond or covalent bond, I am talking about covalent bond only. The covalent bond is formed by the overlap of orbitals. Covalent bond means what? Covalent bond means we have one orbital, another orbital, both have some electron, they will overlap, they will form a bond, right? So there will be overlap of orbitals. That is known as covalent bond. Right now, this overlapping can be of 2 types. It can be either sigma or pi. Now how it is? Let's have a look on this. If the overlap is head on or axial, then it forms if the overlap, that means what I am saying, how covalent bond is formed, let's have a look on this. What we had, let us say we are talking about nitrogen and hydrogen. So nitrogen and hydrogen both had 1 electron each. What they will do, they will overlap their orbitals, and for this it will look something like this. After this overlapping, this is a bond. So bond, covalent bond means what? Overlapping of orbital. One orbital will overlap over the another orbital, right? And this overlapping can be of 2 types. For example, if I have a p orbital was dumbbell shaped. We have studied in bonding. So it can be like this. That means along the axis, one px, another px, both on the x-axis are going on head-on collision. They are going on axial collision. This type of collision will form sigma bond. And if we have py like this and they are going in this direction, then we have py, they are going on x-axis. This is our x-axis. Py and py are moving along each other on which axis? X-axis, right? So if py is moving along x-axis, that will also be a collision. Now such type of collision is parallel collision or non-axial collision. So collision or overlap can be of 2 types. One is that both the orbitals are overlapping along the axis head on, that is formation of sigma bond, and somewhere we can have parallel, that is formation of pi bond. Okay, so sigma bond is formed by head on collision, that we have already studied. Now pi bond is formed by parallel or sidewise collision. Okay, so for sigma and pi bond, we have to understand just two things over here. That bond pair, covalent bond, can be of two types. One is sigma bond, one is pi bond. Right? For sigma bond, what will happen? Any two orbitals will collide along with each other, along the axis. They will collide on the axis. Okay, head-on collision. That will form sigma bond. Now, if collision is parallelly, sidewise, then it will be our pi bond, and sigma bond will be stronger than pi bond. Sigma is always stronger than pi bond. Okay, now let's have some properties of this. Now, first bond formed between any two elements is a sigma bond. Okay, a first bond form, any two element is coming closer to each other, they will form a bond. For example, if I am saying A and B has a single bond, now we have only one bond over here, so single bond, first bond that is formed is always sigma. First bond formed is always sigma. If I have double bond, A double bond B, so double bond is sigma, 1 sigma and 1 pi. If we have a double bond, then first bond will be sigma, another bond will be pi bond. We have 1 sigma, 1 pi bond. Okay. If I have a triple bond, let us say A and B is forming 3 bonds with each other. What I said, first bond is always sigma, so this one will be sigma, and rest 2 will be pi. So here we have 1 sigma bond and 2 pi bond. Okay. So between any two elements, first bond that is formed will be a sigma bond, and after that whatever bond is formed, that will be a pi bond. So single bond will always be sigma, double bond will be 1 sigma, 1 pi, triple bond will be 1 sigma and 2 pi. Let's have an example of the compound. Let's say I have some compound written as C double bond C, double bond C, this is our compound given. Now, if we count number of sigma and pi, what I had said, first bond is sigma, so this will be sigma between carbon hydrogen. Now, between this carbon I have triple bond, so first is sigma, another 2 is pi. Right now, again between these two carbon, this will be sigma. Between carbon and hydrogen, first bond sigma. Between carbon and carbon, first bond sigma, second bond pi. This one is sigma, this one is sigma, here it is sigma, sigma bond, sigma bond, sigma bond, sigma bond and pi bond. So if someone asks me what is the number of sigma and pi bond, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 sigma and 2, 3, 4 pi. So for any given structure like this, if anywhere there is a single bond, we will name it as sigma bond. Anywhere if we have double bond, we will name it as first one as a sigma, other one as a pi. If anywhere I have triple bond, I will name it as first sigma, then 2 pi. Got it? So that's all for our sigma bond and pi bond. So what we have studied in covalent bond till now. Ionic bond we are not discussing in detail, we are detailing just covalent bond. Covalent bond was formed by the sharing of electron, by 50% partnership or 50% investment by both the partners, by both the elements. Then what we studied? Covalent bond can be of two types, sigma bond and pi bond. Sigma bond is head-on collision, pi bond is sidewise collision. Sigma bond is stronger than pi bond. Then in any structure, for single bond will be sigma, double bond will be first sigma, second one pi. Got it? Okay. So we have understood sigma bond, pi bond, we have understood bond pair, lone pair. Now we have to draw different structures of the compound, and for that we will study Lewis dot structure. Lewis dot structure, what it is? First thing, it is not a hard and fast structure. It is not 100% sure structure. It is just a bookkeeping method. Just a it is just a bookkeeping method. Okay, it is not hard and fast. You can say, okay, I have drawn the structure, it will be 100% sure. No, we have to check it by the help of other thing, that is formal charge. So it is our just a bookkeeping method. How to draw it? To draw, first calculate total number of valence electron. Total number of valence electron. First, what we have to do? We have to calculate total number of valence electron. For example, I am taking CH4. Now, what is total number of valence electron over here? It's not for the molecule, it is individually for each element. Now, for carbon, I have 4 electron. For hydrogen, I have 4 electron. In total, we will have 8 electron. Right now, carbon is 4 and hydrogen is 4. Total number of electron will be how much? 8. So we have 8 valence electron over here. Right? Now, out of this 8 valence electron, how to place it? First, we have to find the central and peripheral element. What we have to find? The central element and peripheral element. Okay, this one is our second rule. So first what we did, we had a molecule. We calculated total number of valence electron. How we calculated it? We calculated it by individually for each element. For carbon it was 4, for hydrogen it was 1, that is 4. In total we got how much? 8. Right now, to find central and peripheral element, this was the first thing. Then first thing was total valence electron. Second thing was central and peripheral. What is central? The element that is in between, and peripheral is outside of that. Okay? So what to do? The element with higher covalency. The element with higher covalency, that means the element that can form more number of covalent bond. Okay, so for example, carbon, here carbon can form 4 covalent bond, hydrogen can form 1 covalent bond. The element whichever will have higher covalency will be central element. Okay, so any element that has higher covalency will be central. So here carbon is central and hydrogen is peripheral. So carbon is the central one and hydrogen is the peripheral one. So we have crossed 2 rules, we have understood 2 rules. First was to calculate total number of valence electron, and second was to find out what will be the central, what will be the peripheral. For central, what we see? Covalency. What is the possibility to form covalent bond? The carbon has possibility of forming 4 covalent bond and hydrogen have 1. So hydrogen will be peripheral, carbon will be central. Now next, put a pair of electron between each element. Now here I have 4 element pair, carbon, hydrogen, hydrogen and hydrogen. What I have to do? I have to put a pair of electron. That means I will put one pair of electron here. Either you can represent like this, or we will just represent it by a dot. We have put one pair here, we have put one pair here, we have put one pair here. Okay? So we have put one pair of electron between each element. After that, complete the octet or duet of the central element. Sorry, first we will go for peripheral element. Then what we have to do? We have to complete the octet or duet of the peripheral. That means we have to check. For example, right now I had 8 electrons. In some compound, if I have more than 8, let us say 20 electrons, I put one pair each. After that, what I have to do? Whatever element is in the outside, we have to complete their octet. For example, here we have hydrogen. Hydrogen will have duet. So this hydrogen has complete duet. This hydrogen has complete duet. This hydrogen has complete duet. So all the hydrogens have complete duet, right? So what we have to check? Whether octet or duet of the peripheral element is complete or not. And if it is complete, then it's okay. If it is not complete, if it is incomplete, then I have to put more electron on that element. Okay? We will take some other example. First we will go through the theory. Next, after that, complete the octet of central one. Central element. Now if you look at carbon, so it is surrounded by 4 pair of electron. Right now? And here carbon has 4 pair, that means this octet is complete. This is complete octet. So we have done both the part. We have completed the octet for peripheral, we have completed the octet of central. Right? But maybe we need 20 electrons to complete all of them and we have just 16. We can have that. Total number of valence electron given is less than what is required. Okay? If number of valence electron is less than total required to complete the octet, then we go for formation of double or triple bond. So if we have number of electron that is less than what we need, then we will go for the formation of double and triple bond. Now let's have an example for this. Let's draw for CO2. Now I have to draw the Lewis dot structure of CO2. What was the first rule? We have to calculate total valence electron. In carbon, how many valence electron we have? 4. In oxygen, how many valence electron we have? 6. In total 16. For carbon, what we write? 1s2, 2s2, 2p2. So we have 4 valence electron. In oxygen, what we write? 1s2, 2s2, 2p4. So 6 valence electron we have. So CO2 have total valence electron is 16. Now, first rule is over. We have calculated total number of valence electron. This was our first rule. What was the next one? Find central and peripheral. So carbon forms 4 covalent bond, whereas oxygen generally forms 2 covalent bond. Maximum it can go for 3. So which one is having higher covalency? Carbon. So carbon is having higher covalency. So carbon is our central and oxygen is our peripheral. This is our rule number 2. So rule number 1, rule number 2 we have done. We have calculated total valence electron. We have found what element will be central, what element will be peripheral. What was the next rule? Put a pair of electron. So we put one pair of electron between each element. This was rule 3. Rule 3 done. Now what was next rule? Complete the octet of the peripheral one, outer one. So now I am going to complete the octet of peripheral. What I did? Okay, leave it here. I am just drawing it here. So in the next rule, what I will do. This was till the last rule, and now I am completing the octet. 2 electron, 2 electron, 2 electron, 2 electron, 2 electron, 2 electron. So now after this putting of 6 electron each, now these both oxygen has complete octet, right? So this was our rule number 4. Find valence electron, then find central and peripheral, then put a pair of electron, then complete the octet of peripheral one, outer one. Now then after what we go for? We go for the completion of central one. So in carbon, carbon has 4 electrons. How many extra electron we need? 4. If we put 4 electron on carbon, its octet will be completed, right now? Okay, so we need 4 electron here. But do we have electron? How many electrons we had? 16. How many we have used? Already we have 16 used. So now we need 20 electrons in total, 16 here and 4 for carbon. But what we have right now, just 16. So here number of electron is less than required. So what we will do, we go for the formation of pi bond or double bond and triple bond. What we can do, we will take this electron here and place it here. Okay, now I have 2 electrons representing one bond. So what I am doing, I am putting a pair of electrons from here to here. What it will look like? It will look something like this now. Now again check it. Oxygen 8 electron, carbon 6 electron, oxygen 8 electron. Even now carbon has 2 electron less. So we will go for one more lone pair and convert it to bond pair. So we will have 2 double bond over here. Right now we will have 2 double bonds over here. So now what it will look like? Now the whole structure can be written as C double bond O, C double bond O, and 2 lone pair here. Here this oxygen will have 2 lone pair, 1 sigma and 1 pi. This carbon will have 2 sigma, 2 pi. And this oxygen will have 2 lone pair, 1 sigma, 1 pi. This is our Lewis dot structure for CO2. Okay. So step by step we have understood how to draw the Lewis dot structure. What we have to do, we have to calculate total number of valence electron, then find central and peripheral. After we are done with this, then we will put one pair of electron between central and peripheral. Then we will complete the octet of peripheral. Then we will complete the octet of central. Right? If number of electron is less than required, then we will go for the formation of pi bond. Right? Let's have one more example. Or let's take CO3 minus 2. Because we have already studied carbon oxygen, it will be relatively a little bit easier. So total valence electron will be how much? carbon 4, oxygen 3, and after that minus of minus 2. What does this minus 2 signify? This minus 2 signifies that it has 2 electron more than the neutral one. 2 electron more means what? It has gained 2 electron. Right now? So in total, how many electrons we have here? 24. We have 24 electrons over here. So CO3 minus 2 will have 24 valence electron. Now, carbon has 4 covalent bond. Tendency to form 4 covalent bond. And oxygen has tendency to form 2 covalent bond. So here carbon is having 4 covalent bond, oxygen is having 2 covalent bond, and if we arrange it, what it will look like? Carbon will be the central, oxygen will be the peripheral one, right? Now, next what we will do? COOO. We will put a pair of electron between each. We will put one pair of electron between each. One pair here, and one pair here. After we put one pair of electron, then we will go for the completion of octet of the peripheral one. So we have 3 oxygen, we had put one pair, we put 6 electrons on each. How many electrons we had? We had 24 electrons. How many we have used? 8 on each oxygen, 24. All of them are used. So oxygen has complete octet. Carbon, till now it is not complete. Carbon here has 2 to 4 to 6 electrons only. So what we can do? We can go for the formation of a pi bond and we will put it over here. So carbon will now have a double bond with one oxygen and single bond with other 2 oxygen. So carbon will have double bond with one and single bond with 2. So overall structure will now look something like this: double bond O, single bond O, single bond O. Here we will have 3 lone pair and this one will have 2 lone pair. This is our Lewis dot structure. Lewis dot structure, then if we can draw the structure, why it is a bookkeeping method? Why it is not a hard and fast or secured method to draw a structure? Because everywhere we are trying to fulfill the octet. That means Lewis dot structure is based upon octet rule, right? Lewis dot structure is based upon octet rule and hence it is not a hard and fast method. So what we come to know, कि Lewis dot structure is based on not a hard and fast method to draw the structure of the compound. Okay, it is not a hard and fast method to draw the structure of a compound. So, one more thing that we can understand from here, कि if I am putting in CO2, if I am putting a double bond, what we needed? We needed to form double bond. What we did? We kept one electron from here, another one from here. We can also do that. I will keep one from here, another from here only. Right now? In the same way, in CO3 minus 2, in CO3 minus 2, we can take double bond from here, from this oxygen, or from here, or from here. Right? So either we can have double bond here, here, or here. So in CO2, two structure was possible. One was each with double bond and one was triple bond and single bond. Right? So for CO2 if I see, I had two possible structure. One was C triple bond OO and was C double bond OO. Now which one is correct? Because as per Lewis dot structure we followed everything. Whenever there was a less number of electron, we can go for the pi bond formation. That pi bond formation can be either double bond or triple bond. So we can either go for triple bond, single bond or double bond, double bond. We need two pi bond anyhow. We will be needing two pi bond. Right? So both the pi bond can be between same carbon oxygen or between different carbon oxygen. Now which one is more stable? To check the Lewis dot structure, we need formal charge. What we need to study is formal charge. That will be the last topic for our chemical bonding. Okay. So next topic that we are going to start here is formal charge. Now first thing, as the name suggests, it's not the actual charge on the molecule. It's not the actual charge on the molecule. It is not representing the actual charge. What it is calculating is formal charge. That means, see what happens if we have A and B. I am writing +1 here, doesn't mean that it has taken one electron from here. What happens after bonding? We had two electrons. Now these two electrons can be shifted towards it. But that electronic cloud, those two electronic clouds will not be exactly in the middle. They can be towards B or they can be towards A. Right? What we are trying to say, in that partnership form, in that 50-50% partnership, both are not having equal profit. The smarter one or the, you can say, smarter one I will say, I have not asked the cheater one, will have more profit. They will have more electronic cloud towards themselves. So if electronic cloud is towards A, that means there will be deficiency. It will be called +A, it will be called -A. And if it is towards B, then it will be -1, it will be +1. So it is not an exact charge. It does not mean that someone have lost electron or someone have gained electron. It is just a representation of deficiency or you can say extra electronic cloud. Okay. Now how to calculate it? It takes into account the number of electron after bonding and number of electron before bonding. It takes into account two things. One is number of electron before bonding and number of electron after bonding. Okay. For example, if I have any element A, it is forming B bond, it has one lone pair and it is forming something like this. I am talking about A. What is the number of electron? What is the formal charge then? If anyone asks me what is the formal charge? What is formal charge then? That is number of electron before bonding minus number of electron after bonding. So formal charge is just the calculation of number of electron that any element had before bonding and number of electron that it will have after bonding. That means if I have some amount of electron, if I am losing some electron in bonding, I had 6 before bonding. After bonding I have 5. That means I have lost 1. I will get a plus charge. Okay. Now if I have 6 electrons before bonding and after bonding I have 7, that means I have gained 1 electron. So I will have -1 charge. Very simple. And if number of electron before and after bonding is equal, then it will be 0. Okay. So formal charge is nothing but number of electron before bonding minus number of electron after bonding. So before bonding, what is the number of electron called? Which electron was taking part into bonding? Was it core electron? No. What it was? Valence electron. So before bonding, number of electron will be what? Valence electron. Okay. And after bonding, what we have? After bonding, we can have either bond pair or we can have lone pair. Now this lone pair means what? It is complete property of A. One lone pair means I will have 2 electron with A. But if I have a bond pair, that means 1 electron is of A and 1 electron is of B. Right? So after bonding, electrons can be of 2 types. Either it is lone pair or it is bond pair. Now in bond pair, 2 electrons, each will be with one of the element, and lone pair will be totally with that element. Okay now? So what we will see over here, before bonding electron is valence electron. After bonding it can be either lone pair or bond pair. For each bond pair I will have 1 electron. So valence electron minus bond pair into 1. Because every bond pair has 2 electrons and that will be divided between both the elements. Okay. So bond pair into 1 plus lone pair into 2. Why I am doing that? Lone pair into 2. Because in each lone pair I have 2 electrons and both electron edge with the single element. That's why a one lone pair will be of 2 electrons. So what is our formula now? Formal charge equals to valence electron minus bond pair plus lone pair into 2. So let's calculate for some molecule. For example, I had a molecule like this that we drawn. Here also I will put 1 electron pair each. So formal charge will be for each element separately. Whatever business they have done, whatever profit they have taken, whatever loss they have incurred, that will be for each element. Now let's count about this oxygen. What is the valence electron of oxygen? 6. So before bonding it had 6 electron. After bonding it has 2 lone pair and 2 bond pair. After bonding, what we have? 2 lone pair and 2 bond pair. 2 lone pairs and 2 bond pair. Each lone pair is representing 2 electron and each bond pair is representing 1 electron. So formal charge will be what? Number of electron before bonding, that is 6, minus twice of bond pair, lone pair plus twice of bond pair. Number of lone pair is 2, so into 2. Number of bond pair is 2, so into 1. What we are getting? We are getting 0. That means here we have 0 as the formal charge. This formal charge is 0. Okay now? Now let's count for this one. Valence electron will be same. Oxygen, it will have 6 valence electron. After bonding, it has 3 lone pair and 1 bond pair. Before bonding, we had 6 electron. Now we have 3 lone pair and 1 bond pair. So formal charge for this will be how much? Formal charge will be 6 minus 2 into 3 plus 1. Overall, it will be minus 1. Okay now? So on this oxygen we have minus 1 as the formal charge. Before bonding it had 6 electron. After bonding it is having 7 electron. So in total it has gained 1 electron. So its formal charge will be how much? Minus 1. Again if you calculate for this oxygen, again we have 3 lone pair, right now, and one bond pair. For this it will also be -1. So for oxygen with double bond, formal charge will be 0. For oxygen with single bond, formal charge will be -1. For oxygen with this single bond will be also -1. And if we look for carbon, valence electron is how much? 4. What we have here? Do we have any lone pair? No. What we have? 4 bond pair. So valence electron is 4. Number of bond pair is 4. So formal charge will be how much? So formal charge on carbon will be 0. On oxygen it can be either -1 or 0. Right? Let's calculate for one more, that is NO3 minus. If you look at the structure, it will be N double bond O, single bond O, single bond O, this will be our structure. Okay, so in NO3 minus we have 2 with single bond, 1 with double bond. Now we have to calculate the formal charge. As we have already studied, formal charge of an oxygen that is singly bonded, that will be -1. Okay, same it will be here also. Let's check once. Here what we have, number of valence electron is 6 for this oxygen. How many bond pair we have? 2. How many lone pair we have? 2. So in total you will get how much? 0. Right now? For double bonded oxygen it will be 0. Now what for the single bonded? Again it will be how much? 6 minus 2 into 3 plus 1 into 2. Why? Because we have 1 bond pair and 3 lone pair. So it will be coming out to be -1. Good enough. Now for this one also it will be -1. Single bonded, 3 lone pair, 1 bond pair. Now if we go for nitrogen, how many sigma bond we have? 1, 2, 3 sigma and 1 pi. So we have 4 bond pair. In case of nitrogen, we had valence electron is 5, and after bonding what we have? We have 4 bond pair only. Right now? Just have a look on this. Nitrogen, double bond, single bond, single bond. How many bond we have? 4. What was number of valence electron? 5. So what is formal charge? Formal charge will be 5 minus 4 into 1, in total plus 1. So formal charge on the compound will be 1. Nitrogen, not on the compound, on the element, this nitrogen will be 1. Right? And the sum of all the formal charge will be charge on the compound. So -1 plus 1, overall C we have NO3 minus. Similarly, in CO3, -1 0 0, overall it was CO3 minus 2. Okay, now total sum of all the formal charge will be charge equal to charge on the molecule. Okay, so we have understood how to calculate the formal charge. What is formal charge? The formal charge is basically the calculation of loss or profit on the number of electron. Simple enough. It is just the calculation of gain or loss of electron by any element when it undergoes bonding. Now how do we check it or use it to check the Lewis dot structure? That was our question from where we started studying formal charge. The simple rule is that smaller the value of smaller the formal charge, more the stability. Smaller the form, either plus or minus, we will not take it as algebraic number. We will not say that -1 is lower than 0. Okay, both are just a charge, just opposite in nature. That's why one is plus, one is minus. So here what we see is smaller the formal charge, more the stability. So if In any compound, if in any compound we are drawing Lewis dot structure, say that I am drawing Lewis dot structure of a compound. That was, we had taken CO2 only. Now in case of CO2, I had two possibilities. One was double bond oxygen, and one was with triple bond oxygen. So we have two possible structures over here. Look over here. So in one, I have double bond with each oxygen. In another one, I have triple bond with one, single bond with one. Carbon, here we have 4 bond pair, 4 bond pair. So on charge on carbon will be 0. That is simple enough. Carbon has 4 valence electron, and after bonding, it has 4 bond pair at both the place. So carbon will have 0 as its formal charge. Now if you look at oxygen, so here oxygen has double bond, right now? Oxygen is having double bond. And what we have seen till now, double bonded oxygen will have 0 as the valence, as the formal charge. Why? Because we have 1, 2, 3, 4, 5, 6. Out of 2 bond, I have taken 2 electron. For 2 lone pair, I have taken 4. So this oxygen will be 0. This oxygen will also be 0. So in CO2, first structure, formal charge of all the element is 0. Whereas in the another one, if I look at this, it will be -1, simple, single bonded. What it will be? 6 minus 3 lone pair and 1 bond pair. Now here what we have? Here I have 6 minus 2 into 2. Sorry, not 2 into 2. 1 into 2. We have 1 bond, 1 lone pair only. 1 into 2 plus 3 into 1. We have 1 lone pair and 3 bond pair. For 1 lone pair, I will be taking 2 electrons. 3 bond pair, I will be taking just 3 electrons. In total, how many electrons we have? 6 minus 5, that is +1. So here we have +1 and -1. And here everyone is 0. Net charge on the molecule is 0. Net charge of -1 plus 1 sums up to be 0. That is not a problem for us. But for individual element, what we know is smaller the value of formal charge, more the stability. So now what we understand over here, CO2 can have two possible structure, one with double bond, one with triple bond. Here formal charge on each is 0. Here formal charge is +1 and -1. So net charge is 0 on both, but which one will be stable? This one is more stable. Why? Less the formal charge, more the stability of the compound. That's why for CO2 we had drawn this structure, not this structure. Okay, so lower the formal charge, more the stability. This is the end for chemical bonding of our CBC program. Next we have to study, as I have said, after the failure of octet rule, we have to study two more things, that is VBT and MOT, valence bond theory and molecular orbital theory. But that will be in the part of class 11, where we will study in detail all these things: sigma bond, pi bond, Lewis dot structure, what is the loophole, how can we rectify it. Okay, then we will also study for the ionic compound, their properties of covalent compound, all we will study over there. So till now what we have understood in bonding, let's sum it up once. What was it? It started with why bonding takes place, to gain stability. How? By losing potential energy. What we approached first? Octet rule. Why we approached it? Because noble gases were having stable electronic configuration, they were less inert, and it was shown by few compounds. But later on what we found, that noble gas itself undergoes chemical reaction. That means it can't be the frame of reference for the stability. They are not ultimately stable. And besides, we also come to know about compounds that have more than 8 electrons. and also come to know about the compound that have less than 8 electrons. So they are hyperoctet and hypooctet. So due to all these things, octet rule failed. After that, we understood that while bonding, we can have bond pair, we can have lone pair. In bond pair, we can have single bond or multiple bond. Single bond will be sigma. In multiple bond, double bond, I have 1 sigma, 1 pi. In triple bond, I have 1 sigma, 2 pi. Then we started to draw Lewis dot structure. And after Lewis dot structure, then we studied formal chart to check which Lewis dot structure will be more stable. So now for the next class, our homework will be DPP 10 and 11. That is for bonding. And this is our homework that we will discuss in the next class. And right now you will have a break of 10 minutes. On the next class, we will start after that. So bye everyone. This is the homework for the weekend. We will discuss it in the next class.
Good morning to all of you. Let us continue with the problems on graph. The velocity, we are continuing with yesterday. Yesterday, whatever problems we have done, the problems are continued related to velocity time graph. Your day 10, whatever assignment you have, classwork and homework, that will be mixed problems on both the graph, displacement time graph, velocity time graph, one or two questions maybe on acceleration time graph. Let us continue with this. The velocity time graph for a moving object is shown in the figure. They have given you on x-axis time, on y-axis velocity. Graph, check properly. The total displacement of the object during the time interval when there is non-zero acceleration and retardation. The first, you identify where you have non-zero acceleration and retardation. So if you are checking here, if you check here, velocity here is constant, means acceleration is 0. We will not have to consider that. So we have to consider here it is accelerated, here it is retarded, means we will have to consider this much area. This much area you draw like this. So from here till here, they are asking you total displacement. You have to consider acceleration as well as retardation. It means that if they will ask only for acceleration, I will consider only this much. If they will ask only retardation, we'll consider this much. But here, total they are asking you. So from here till here it is 20. This area you take 20. So this is 20 into 1 meter. This is this area. 40 minus 20 is 20 into 1. And now this is a triangle. So for this you will have to add half. Base is 20 and height is 1 to 4. So 4 minus 1 is 3. So you will multiply it by 3. So 2, 10 times. This is 30 meter and this is 20 meter. You are adding. How much you are getting? 50 meter. Your answer is 50 meter. How you have considered? Area of velocity time graph will give you displacement. In the problem, they have given you a specific area you should consider where body is either accelerated or retarded. So we have considered first this. This is accelerated and this part is retarded. We have added these two. Simple, it is rectangle, it's triangle. Simple formula you have used for area of rectangle and triangle. You added, you got 50 meter. Move to next question. They have given you 4 cars, A, B, C, and D, moving on a leveled straight road. 4 cars are there. They are moving on a road. Their distance time graph are shown in the given figure. So here they have given you the graph. Which of the following is the correct statement regarding the motion of these cars? First, you check the graph. Graph is distance versus time. If I take slope of this, it will give me speed. The slope, you check. This one is theta B, this one is theta A, this one is theta D, this one is theta C. And so tan theta C greater than tan theta D greater than tan theta A, and it is greater than tan theta B. What do you mean by that? It means that speed of C is greater than speed of D is greater than speed of A greater than speed of B. Correct? Now, in your hand, this one is there. Now, check the alternate. Car A is faster than D. If you see here, D is faster than A is wrong. Car B is the slowest one. You check here, car B is slowest one because its speed is minimum in comparison to speeds of other three. So this is correct statement. Car D is faster than car C. No. Car C is faster than D because velocity of car C is more than velocity of D. Car C is slowest one. Car C is the fastest one. So answer is B. Let us move to next question. Uniform acceleration of the body from rest is represented by, here they have not given you the graph. You can check. Uniform acceleration of the body from rest is represented by 1, 2, 3, 4. They have not given you, actually there should be 4 graphs. In those 4 graphs, one you will have to tick. In the figure, it's not there. Okay? So, you will have to go for next. The body is starting with uniform acceleration that becomes 0 is represented by, I think, figure. Yeah. That one, in that question's figure will not be there. Figure already is not there. Okay, no. So when figure is not there, you cannot solve this question. Okay, no. You have missed. They have not given at all. Okay, no. So, uniform acceleration of the body from rest is represented by, there must be 4 figures in the problem. Because not a single figure is being given, we cannot solve this question. You cannot solve also this. You can't. So let us go for the class work. In the speed time graph, for a moving object shown here, they have given you a speed time graph. Okay. The part which indicates uniform retardation of the object is, each part let us understand. In this question, they had asked you only one. Uniform retardation they had asked you, but each part you check. If I go for this part, speed is constant. If I go for this part, it is uniformly accelerated because slope is positive. If I go for this part, it is uniformly retarded. And again you go for this part, your speed is constant, means acceleration is 0. So for this particular problem, they are asking you uniform retardation, your part is RS, your answer is C. Let us move to next question. They have given you the graph between the displacement and time for a particle. Check the graph properly. Moving in a straight line is shown in the figure. This is the figure. During the interval OA, AB, BC, and CD, they are asking you acceleration of the particle is. For the part OA, if you see, if I will go like this, and OA part, if I consider, this is OA part. right? This is your OA part. OA. If you check here, slope, you know displacement versus time, slope will give you velocity. If you take slope here, okay, no, check, slope is going on decreasing. If slope is decreasing, it means velocity is decreasing. Velocity is decreasing, it means its motion is retarded. They are telling you particle is moving along a straight line path. Suppose it is positive x-axis, the O2A, they are asking about acceleration. The retardation is nothing but negative of acceleration. So you will have O2A negative. Negative means either this or this. It is negative. Now, A to B is a straight line. If you take a straight line, it means your particle is at rest. Displacement is not changing, so you will have 0. All four are 0. So here or here, both are right. Next, you will have to consider, okay, part BC. Now for BC, if you consider what happens, your BC, the graph goes like this. The slope is going on increasing. If this is theta 1, this is theta 2, your theta 2 is greater than theta 1, slope is increasing, means motion is uniformly accelerated. So positive, here is positive, here is negative. And then for CD part, you see it is just a straight line. If you take a straight line, it means that velocity is constant. So if you take velocity constant, it means there is no acceleration, it is 0. Your answer is B. The OA part acceleration is negative, AB part acceleration is 0, BC part acceleration is positive, CD part again your acceleration is 0. Here displacement is constant, it means velocity is 0, acceleration is also 0. For CD part, you have velocity, constant velocity, but acceleration is 0. Clear to you? Let us move to now next question. Which of the following velocity time graph represent uniform motion? Uniform motion means velocity should remain constant. Clear? So if you take these four, directly we can take A, because velocity remains constant. If you go for B, velocity is gradually going on increasing, so it is uniform acceleration. Velocity here is going on decreasing, and there you just check velocity is here acceleration is constant. The answer for this uniform motion, velocity should be constant. Answer is A. Now, let us move to next question. They have given you graph. Graph given alongside, okay, shown the positions of a body at different times. Calculate the speed of the body as it moves from. Speed, they are asking you speed of the body. Speed is slope of displacement time graph. If you go from A to B, I need this tan, this angle you are representing by theta, then you need tan theta. So this one from here till here, it is in meter, it is 3. And this is 0 to 5, it is 5. Okay, no? Check. This is 3, distance in meter. So this one is 3 meter and this one is 5 second, 0.6 meter per second. So A to B, it is 0, okay, 0.6 meter per second. Now they are telling you B to C. B to C, they are asking you speed of the body. So what will be slope of displacement time graph or is distance versus time graph? If you take here slope for BC, slope is 0, so speed of the body. This is for A. For B, your slope is 0, so particle is at rest, distance is not changing, so speed is 0. Now, you are going from C to D. So, C to D, you will have to take this angle. Now, here, your tan theta, if this angle is theta, so this distance you will have to take divided by this distance. This distance here is 3, here is 7. It will be 7 minus 3. And this is 9, this is 7. So this will be 9 minus 7. It is 4 by 2. Your speed, no, 2 meter per second. So answer for the speed from A to B, 0.6 meter per second. B to C, it is 0. And from C to D, it is 2 meter per second. Now, let us move to next question. Given alongside is the velocity time graph for a moving body. Find velocity of the body at point C. See, graph itself is velocity versus time. You can get instantaneous velocity at any point. Check, they are asking you velocity at point C. So this is point C, and at C, your velocity is 40 kilometer per hour. So answer 40 kilometer per hour. Clear to you? Next, acceleration acting on the body in between A and B. Slope of velocity time graph gives you acceleration. So I will take slope in between A to B. This is A to B. You have to take this slope. So this slope will be how much? Acceleration will be equal to 40 minus 20 divided by this distance is 3 seconds. Okay, no, this will become 20 by 3 and it will become kilometer hour squared. This unit is kilometer per hour. Kilometer per hour, and this one is already hour, so hour squared. Answer is 20 by 3 kilometer per hour. Next, they ask you acceleration acting on the body between B and C. You can check. This is B, this is C. What is slope? Your slope in between B and C is 0. When slope is 0, acceleration is 0. So your answer is 20 by 3 for this kilometer per hour squared, and here B to C, it is 0. Clear to you? Easy, no? Now, you have in CBC book, so many questions they had given you on the graph. It means that basics related to displacement time graph and velocity time graph you should know nicely. Let us move to next question. Figure below, they have given you one figure. See the figure. Shows the graph of x coordinate of a particle going along x-axis as a function of time. So, you have a graph displacement versus time. Find the average velocity from 0 to 10 seconds. Means here till here. Okay, no? Your A bit, they are asking you average velocity. In the beginning, I have taught you average velocity is net displacement by total time taken. If I take from 0 to 10 seconds, net displacement here is at t equal to 0 second, its displacement is 0. And at t equal to 10 second, it is 100 meter. So, average velocity will be 100 divided by total time taken. Undoubtedly, if you take this part, means 2.5 to 7.5, means for 5 seconds, particle is at rest. You have to consider even the time during which particle is at rest in the process of journey. Particle is moving along x direction. Somewhere particle had come to rest, that time also you will have to consider. So, here 0 to 10 second means 10 second. This is meter, this is second, you are getting 10 meter per second. Now, go for B bit, instantaneous velocity at 2, 5, 8 and 125 is not there, perhaps it will be 12.5 beta, 12.5 second. The first you take instantaneous velocity at 2. The 2 if you take, they are asking you here this is a straight line. Okay, no. So, whatever instantaneous velocity will be there, particle is moving with uniform velocity. Instantaneous velocity will be equal to whatever uniform velocity you are getting, means you will have to take slope of displacement time graph. So, this is 50. So, you will have first answer, you are taking V instantaneous, first you take at 2 second, at 2 second it will be 50 by 2.5. 2.5 means 25 by 2. You are taking 2.5, no? So, 2.5 directly 50 by 5 by 2. This will become 20 meter per second. Clear to you? Now, at 5 second, here you go, check your displacement is not changing at all. If displacement is not changing, then what will be the slope? Slope will be 0. What will be velocity? Velocity will be 0. So, V instantaneous at 5 second, it is 0. V instantaneous at, next they have told you at 8 second. 8 second is somewhere here, means I must take slope of this angle. So, this is 100 minus 50, okay, at 8 second. So, this will become 100 minus 50 means 50 divided by this time is 2.5. 50 by 2.5, again it is 20 meter per second. Clear to you? This is at 8 second. And then they are asking you 12.5 second. The 12.5 second is here. So, you will have to take this slope. So, instantaneous velocity at 12.5 second, you have to take this slope. So, for this distance you take it is 100, and This time is 5, 15 minus 10, 5. This will become equal to 20 meter per second. So your all answers are clear to you. First answer, instantaneous velocity at 2 seconds, 20 meter per second. At 5 seconds, it is 0. At 8 seconds, it is 20 meter per second. Okay, and at 12.5 seconds, again you have taken slope. Your answer is 20 meter per second. Let us move to next question now. Draw a velocity time graph to show the following motion. They are telling you to plot a graph. Actually, you need a graph paper. Okay, no? But roughly on the paper we can draw. Car is accelerating. First thing, they are asking you velocity time graph. I told you time is a fundamental physical quantity. Your velocity will depend upon time. You will be considering time on x-axis and velocity on y-axis. So this is 0. I am taking time on x-axis, velocity on y-axis. Car is accelerating uniformly from rest for 5 seconds. So car is accelerating means slope must remain constant, uniform acceleration. Okay, no? Slope at every point should be same for 5 seconds. So you are considering here this time is 5 seconds. Then it travels at a steady velocity for further 5 seconds. So from here they say you it is moving with constant velocity. The velocity must remain constant. So this will become like this straight line up to what time? For further 5 seconds, means this will become 10 seconds. Check the nature of graph. I hope you are understanding. Up to 5 seconds, you have taken uniform acceleration, and from 5 to 10 seconds, for 5 seconds, it is just a line, a straight line parallel to time axis, because particle is moving with constant velocity. Now, let us move to next question. A car is moving on a straight road with uniform acceleration. Okay. The speed of the car varies with time as follows. They have given you speed 0, time is 0 second, speed is 4. Time is 2 second, speed is 8. Time is 4 second, it is 12. Again, you need here to this type of problem, you need a graph paper. Okay, no? For me, on board, roughly I'll be drawing. At 6 second, it is 16. At 8 second, it is 20. At 10 second, it is 24. They are asking you, they have given you time and speed. They are telling you draw the speed time graph. For choosing a convenient scale from this graph, the first you will have to plot a graph. So I am taking here time 0, 2, 4, 6, 8, and 10. Okay. And you are telling you that speed on y-axis I am taking 4, 8, 12. If I assume this as 4, this will be 8, this will be 12, this will be 16, and this will be 20, this will be 24. If graph paper is not there, then roughly equal distances you should consider. Now, they say you This is velocity versus time. They say you at 0 second, speed is 4. It is here. At 2, it is 8. The 2 here. How to plot? I am showing you. It is here. At 4, it is at 12. So you will go here. From here, it will come like this. It is here. At 6, it is at 16. At 6, you will come from here. It is 16. At 8, it is at 20. It is 8. You are coming here. From here, you are coming. At 10 seconds, it is at 24 meter per second. You are going like this, and it is here. So your point is here. So what is the nature of graph? Join all these points, you are getting a straight line. This is just a straight line graph, right? You have a straight line graph. Now, they are asking you, calculate the acceleration of the car. Acceleration of the car will be given by slope of velocity time graph. So I need slope. Okay, no. If you are taking slope, you go for 24 minus 4. Okay, no. So I am taking slope for this, means this angle tan theta I need. Your tan theta equal to this distance is 24 minus 4. By this time, you will be taking 10. So it is 20 by 10 2 meter per second square. Your acceleration of the car is 2 meter per second square. Calculate the distance traveled by the car in 10 seconds. If you want total distance traveled by the car in 10 seconds, then total area you have to consider. So why not we'll draw a separate figure. It will be easier for us. This is 4 meter per second. This one is 24 meter per second. And now area enclosed by this. So this total area you will be considering this area plus this area. The area of VT graph will give you total distance covered. Okay, no? So you will have this. If you take 4, okay, no? This is 4 and this is 10. 10 into 4 is how much? 40. This area I am taking A1, this area I am taking A2. Your A1 equal to 10 into 4, 40 meter, and A2, if you go for that, meter per second into second, second cancel, so unit will be meter. This is triangle, half, base is 10, and height, this is 24 minus 4, this is 20, 24 minus 4, 20, this is 10. So you will have 10 into 20, 2, 10 times, this is 100 meter. The total will become 140 meter. The distance traveled by the car in 10 seconds will become 140 meter. Is it clear to you? Now, let us move to next question. Figure shows the graph of velocity versus time for a particle going along x-axis. Just now we have plotted identical graph. And they are asking you acceleration. Again, same concept. You will be taking velocity versus time graph, you will be considering slope. Acceleration will be ready. The slope will be how much? You will take like this. The acceleration will be equal to this distance. 8 minus 2 is 6. This is 8 beta. And this is 2. 8 minus 2 is 6. This is 10. You are getting 0.6 meter per second squared. The distance traveled in 0 to 10 seconds, completely identical problem to how much total distance it is covering. So this is 10 into 2, 20 plus half into base is 10, height is 8 minus 2, 6. So 2, 5 times 30 plus 20, answer is 50 meter. Clear to you? Now, the displacement in 0 to 10 seconds. Check, they have given you distance and displacement, right? Particle had moved with constant acceleration, means it has moved along a straight line path. Acceleration is constant, velocity is continuously, gradually going on increasing. So distance and displacement will be equal. So your answer will be 50 meter. Clear to you? The answer for acceleration 0.6, distance and displacement from 0 to 10 seconds, both it will be 50 meter. Now move to next question. If the displacement of an object is proportional to a square of time, if I have s proportional to t squared, right now, check actually by differentiation in one line you can say how s equal to k t squared, where k is constant of proportionality. Clear? Now differentiate ds by dt, it will become 2kt, means this is your velocity. Means velocity is a function of time, linearly velocity is going on increasing. If further if you differentiate, then you will get acceleration dv by dt, this one you are getting 2k, means acceleration will become constant. If acceleration is constant, means particle uniform acceleration. For uniform velocity beta, velocity should not be a function of time. Then this, if this quantity is constant, then you can say that particle is moving with uniform velocity. Right now, increasing acceleration, a will be a function of time and it should be a positive quantity. So here your answer is uniform acceleration because acceleration is constant. Now let us move to next question. Acceleration versus time graph of a body is shown to you. The corresponding velocity time graph, I told you just one or two questions are based on. Check, this is the graph. From here, time they have not told. Let us take this is t1, this is 0, this is t2, this is t3. The 0 to t1, your acceleration is constant. Particle is moving with uniform acceleration. Okay, no? Acceleration is constant. If acceleration is constant, then velocity will be going on increasing. Slope will be positive and it will be constant. So here, if this part will be, this time you take 0, this one you take t1, right? t1 to t2, your acceleration is 0. You see here, T1 to T2, your acceleration is 0. If acceleration is 0, it means that had moved with constant velocity. It means that from here till here, velocity is constant. From here till here means this time you take as T2. And then check again. Again, now your acceleration becomes constant. Okay, no. Here it is retarded. Acceleration is not constant. Motion is retarded. So this part you cannot take. 0 to T1, if you go for here, acceleration, velocity is constant, then again it has attained same value. Means acceleration has attained the same value. How it is possible? It is possible under only one condition, that here slope, and if you take here slope, these two slope will remain constant. Angle made by this line with time axis, and here angle made by this line with x-axis, horizontal line, these two angles should be equal. The answer will be C. No need of considering B or D, only will have to think about A and C. A and C, it is fine. But T2 to T3, here, okay, no. Here it is retardation, here you have acceleration. So you have to consider answer C. Now, let us move to next question. A bullet of mass to a bullet horizontally with a velocity of 160 meter per second. I have a bullet mass is 10 gram, means 10 into 10 to the power minus 3 kilogram. It's traveling horizontally with a velocity, okay, u 160 meter per second. It strikes because if it will strike, problem will be complicated, because block also will move certain distance and bullet will penetrate also. Have to assume that wooden block is fixed, stationary, and comes to rest in time. They have given you 2 10 to the power minus 2 second. The distance of penetration of the bullet into the block will, okay, no, it means it has come to rest. It has gone inside. Rest, it means V is 0. Okay, no, its velocity is 0. I will be taking, I need acceleration. So V equal to u minus 80, it is 0, it is 160 minus a, t is 2 10 to the power minus 2, a will become 160 by 2 10 to the power minus 2 meter per second square. It is 280 into 10 to the power minus 2, this is 8, minus 2 will become plus 2 when it will go up, 8 10 to the power 3 meter per second square. So your acceleration so we will be using V square u square minus 2as. This is 0. U 160 square minus 2 A S 160 into 160 by 2A. 2. A you got 8 10 to the power 3. Clear to you? Now, how much it is? It is 16. 8 and 2 16. This will become taking like this, it is 1.6. This will be the answer. And after finding retardation, we have calculated displacement. Two equations of motions we have taken, and third one, v square equal to u square minus 2as. Again, minus sign I have taken because of retardation. Move to starts from rest and move Perhaps you were not able to hear me. There may be some technical problem. Now, you would be capable to hear now. Are you listening me clearly? Now, come back. So, I was speaking about Newton's laws of motion, first law. I was telling you about inertial frame of reference. First frame of reference, for that, 3 dimensions, what you have done, you have taken one origin, x-axis, y-axis, and z-axis. Clear to you? X, y, and z you have taken. This is frame of reference. Now it is of 2 types, inertial frame of reference and non-inertial frame of reference. If you are considering rest and motion relative term, first you will have to decide a frame of reference. Just now I was quoting you example related to a person sitting in a train. When train is moving, the person sitting in train with respect to a co-passenger, he is at rest. Their frame of reference is fixed with respect to train. In that frame of reference, that man is at rest. But with respect to a person who is standing on platform and that train is crossing in front of platform, with respect to that person, the person sitting in train is in motion. If your frame of reference is fixed with respect to ground, then that man is motion. Same, change frame of reference, motion is changed. A particle would be at rest or particle will be in motion. The rest and motion will never have absolute meaning according to Newton's first law. Now, inertia. You are considering now concept number 2, inertia. According to Newton's first law, any body which is at rest want to be at rest. If a body is moving along a straight line path with constant velocity, means it has uniform motion. A particle moves with uniform velocity, then it will like to continue to move with constant velocity. Particle will be moving with constant velocity or particle will be at rest. Based on this, you are telling inertia of rest, inertia of motion along a straight line path, inertia of direction. Inertia of rest. Okay, no? The inertness or inability or incapability, any one word you can use. The inability, incapability or inertness of a body to change its initial state by itself is known as inertia of rest. Means if you want to change its initial state, guaranteed some external agency will have to exert force. Direct line I told you. If no net force is acting on the body, body will like to continue its initial state of rest. So many examples you have. Okay, no? Suppose you are sitting on a bike, in a car, and all of a sudden bike has started. What will happen? The lower part of your body is in contact with bike. The moment bike would start, bike will move in forward direction, so lower part of the body will move in forward direction, but upper part of the body will like to be at rest. You'll get a jerk in backward direction, because upper part of the body want to be continuing its initial state of rest. I was demonstrating in a very simple way. I was taking a cup. In the cup, I was putting a big rod. Okay, no? And on the top of the rod, I was putting a coin. Very small bowl I was taking. Okay, no? In Hindi, you people are telling katora, no? Okay, while taking food, in that you are taking curry. A small cup. And a small, okay, no? Linear rod. Wooden rod you take, no problem, cylindrical rod. Thickness you take that much, you can keep a coin. 5 rupees coin nowadays is available, 1 rupee coin, 2 rupee coin, any one coin you keep. Take one more rod. Bowl is very small, beta, just this much bowl, and here is the rod, and on the top of this you have kept the coin, and with other rod you hit it. When you are hitting it, then it will fall like this. A coin is on the top. I will give you rod and I will tell you hit it in such a way that coin should, okay, no, fall outside of the bowl. This is bowl, katora, cup, and here is the coin. You will think that array rod is so long, coin is on the top, bowl is only this much. When this rod will fall, coin will fall outside. Right? But when you are heating it, what will happen? Coin, you are not heating coin, you are heating the rod. Okay, no? And here, friction is very, very less, negligible. So what will happen? Rod will move outside, coin want to continue its initial state of rest. So, rod will fall outside and coin will fall down in the bowl. You will be surprised. Clear to you? And it is happening due to inertia of rest. And at home, you have so many examples related to this. Your bed sheet, blanket, you are giving jerk. 2 persons will be holding the blanket, the ends of blanket, and they are giving jerk to remove the dust particles. Actually, if you will give jerk like this, again dust particle will fall on carpet or whatever blanket you are taking or bed sheet you are taking. Actually, after giving jerk, you will have to move like this so that dust particles should fall on the ground. You have given a jerk to blanket, right? No. The dust particle wants to be at rest. So you are removing the carpet or blanket away, dust particle wants to be at rest, so blanket had moved away, dust particle will have free fall on the ground. Is it clear? Numerous, plenty of examples you have on inertia of rest. But since time is over, I will continue this topic in my next class. Whenever my next class will be there, I'll continue with Newton's first law. Today, just I have given the statement. I have told you about rest and motion, and just I started inertia of rest. Means I am still on Newton's first law. I will explain you a bit in depth Newton's laws of motion. Till here I am keeping now. You will have now 10-minute break. After that your math class will start. Okay? Thank you. Have a nice day.
Good morning, students. So yesterday we have discussed GP. I guess we have completed AP. Now today we'll be doing questions on GP and we will be also doing infinite GP. All right? Just a minute. Okay, let's start. This is the first question, right? The sum of all terms of a GP is 5 times the sum of odd terms. The common ratio is, right? The total number of terms can be even, right? They have given total number of terms be what? Oops. Total number of terms are even, right? So let's say the terms are AR, right? AR square, so on, right? This is the GP, correct? And they are saying the sum of all term. What is the sum of all term? Sn formula. Sn will be how much? A into 1 minus r to the power n upon 1 minus r, right? A into 1 minus r to the power n upon 1 minus r is, now this Sn, they have given it is 5 times the sum of odd terms, right? 5 times the sum of odd term. So if I just see the odd terms, this is AR, next will be what? AR cube, right? Next will be AR to the power 5, correct? So if I see, this is also forming a GP, right? This is also forming a GP. And if it is forming a GP, then it is forming a GP, right? Then what I can say, its common ratio, this common ratio is how much? R square, right? It is common ratio is how much? R square. And for this, you will see that in 4 terms, there are two odd terms, right? If I see in 4 terms, there are 2 odd terms. Similarly, in 6 terms, there are 3 odd terms. So if there are n terms or all of them are even, then can I say that it is equal to 5 times, what will be the sum of odd terms? First term will be AR, right? 1 minus R square, right? Why? R for odd terms is how much? R square. And number of terms is actually n by 2, right? I told you, just if there are 4 terms, total number of odd terms are how many? 2. If there are 6 terms, total number of odd terms is what? Half of it, 3. Similarly, if there are n terms, total number of half terms will be how much? N by 2, right? Upon 1 minus r square, right? Upon 1 minus r, which is in this case is r square. Okay. So if I see this, a and a will cancel, correct? This 2 and 2 will cancel. What this will become? 1 minus r to the power n. And this will also cancel with this one, correct? Okay. And 1 minus r square will be factorized with 1 minus r and 1 plus r, right? It will factorize into this. So 1 minus r and 1 minus r is cancelled, right? Now what I will have? I will have 1 plus r is equal to 5r, right? 1 plus r is equal to 5r. What are they saying? The common ratio, right? So what I can say? I think 5r, right? Correct. So we can say that 1 is equal to 4r or r equal to 1 by 4, right? The sum of all terms GP is 5 times the sum of odd term. Okay, I think we have taken 5 here. This is 5 times, right? This is 5 times. So 5 will not be this side, it will be this side. 5 into 1 plus r, right? If I do 5 into 1 plus r, I'll be getting 5 plus 5r, right, equal to r, right? From there you can get the answer, correct? Okay. Then 4th and 7th term of a GP are 54 and 1458 respectively. The first term is what, right? 4th term of a GP, T4, they have given to be how much? 54. And T7, they have given to be how much? 1458. Right? They have given to me how much? 1458. What is T4? T4 is AR cube. It is equal to what? 54. Right? It is equal to what? 54. And what is T7? AR to the power 6, which is equal to 1458. Correct? Now if you divide this two, you will get R cube. So if I just divide them, AR to the power 6 divided by AR cube, you will get 1458 divided by 54. Correct? A and A will cancel. correct? R cube and R6 is cancelled, so you will get R to the power 3, right? R to the power 3. And here you have 1458 divided by 54. I think this should be going to 54, right? I guess 27 times, right? 27 times, okay? So R will be equal to what? 3, right? R will be equal to what? 3. If R is 3, you can plug it in here and get the value of A. So if I write, and anyway we know R cube is 27, so I can write A into 27 is equal to 54. So A will be how much? 2. A will be how much? Because they're asking the first term, so A is how much? 2. Correct? Right? I hope this is clear to everyone. Next. The first term of a GP is 1. The sum of third and fifth term is 90. Sum of third and fifth term is 90, right? T3 and T5 is what? 90. Find the common ratio of the GP, right? So what will be T3? T3 will be AR square. And what will be T5? T5 will be what? 90. Sorry, T5 they have given, oops. T5 will be AR to the power 4, right? AR to the power 4. Now they have given their sum is how much? 90. So can I say that T3 plus T5 should be equal to 90, right? So I can say that AR square plus AR to the power 4 is equal to 90. Right, is equal to 90. But they have given A is how much? 1. If I write A1 here, what I will get? I will get R to the power 4 plus R square equal to 90. Right? It means R to the power 4 plus R square minus 90 equal to 0. Right? R to the power 4 plus R square minus 90 is equal to 0. Correct? Now you will see the factors. So when you factorize this, you will have R to the power 4 plus 10R square minus 9R square, right? Minus 90 is equal to 0, right? Now you will take R square common, so it will become R square plus 10 minus 9, R square plus 10 is equal to 0, right? So I can say from here that R square minus 9 equal to 0 or R square plus 10 equal to 0. It means that R square equal to 9. It means that R is equal to plus or minus 3. Right? R is equal to plus or minus 3. And from here, I will have R square is equal to minus 10. Right? R is a real number. So R cannot be minus square of it, which cannot be minus 10. So this will be cancelled out. Right? So what will be the common ratio of the GP as they have asked? It will be plus or minus 3. Right? Just not plus 3 or minus 3. It is plus and minus 3. Okay, next question. If x plus 9, x minus 6, 4 are in GP, then the value of x is equal to what? Right? Then the value of x is equal to what? Okay, yesterday I think I told you if A, B, C are in AP, right? Then what I can say, B minus A is equal to C minus A, C minus B. Then I can write 2B is equal to A plus C. Right? I can write 2B is equal to A plus C, or I can say B is equal to A plus C by 2. Please remember this. Or B is equal to what? A plus C by 2. Correct? Now let's understand if three terms are in GP, then what happens? So let's say now this time A, B, C are in what? GP. If they are in GP, then what can I say? I can say B upon A is equal to C upon B. Right? B upon A is equal to C upon B. If I cross multiply, what will I get? I will get B square is equal to AC. Right? I will get B square is equal to AC. So this is the one condition. Or I can write B is equal to square root of AC. Right? This is the condition for three terms to be in what? GP. Please remember this. This is the condition for three terms to be in AP. This is the condition for three terms to be in GP. Alright, now what are they saying? They are saying that these three terms, x plus 9, x minus 6 and 4 are in GP. Then I can say from this particular thing that the middle term square, that is x minus 6 square, x minus 6 square will be equal to what? X plus 9 into 4, right? It will be equal to what? X plus 9 into 4. If I expand this, what will I get? I will get x square minus 12x plus 36 is equal to 4x plus 36. Correct? 4x plus 36. Now, I can cancel this and this, right? I will bring this side, so I will have x square minus 16x is equal to 0. So I can write x into x minus 16 is equal to 0. It means that either x is equal to 0 or x is equal to 16, right? X is equal to 0 or x is equal to 16. There is no 0 in this, right? So the correct answer for this one will be how much? C. Option C. Understood? I hope this is clear to everyone, right? Option C, fourth question, right? All these questions were also easy, just like a very basic questions of GP, right? Okay, next question. In a GP, the ratio of sum of first three terms, the ratio of sum of first three terms and the first six terms, right, is 125 upon 152. 125 upon 152. Then the common ratio is equal to what, right? Then the common ratio is equal to what? Okay, let's see. So basically they are saying sum of first three terms, that is S3 upon S6, right? S3 upon X6, they have given it to be how much? 125 divided by 152, right? 125 divided by 152. I will just apply the formula of S3 and S6. What is the formula of S3? It is A into 1 minus R to the power cube upon 1 minus R. And what about S6? It will be A into 1 minus R to the power 6 upon 1 minus R. Right? Now 1 minus R cancel, A and A cancel. Right? It is equal to given to be how much? 125 divided by 152. Right? 125 divided by what? 152. Now if I factorize this, right? This is A minus B and A plus B. So what I will get? 1 minus R cube is there in numerator. In denominator we have 1 minus R cube into 1 plus R cube, right? It is equal to what? 125 divided by 152. Correct? Okay. Now this and this will cancel, right? This will go on this side and this, everything will come on this side, right? So what I will have? I will have 152, this whole bracket. 152 divided by 125 is equal to 1 plus R cube, right? Is equal to 1 plus R cube. Now if I send this 1 on this side, what I will have? I'll have 152 divided by 125 minus 1 equal to R cube, right? Minus 1 equal to what? R cube. So can I write R cube is equal to 152 minus 125, 152 minus 125 divided by 125, right? And what is 152 minus 25? R cube will be equal to what? 27 upon 125, right? So R will be equal to 3 by 5, right? R will be equal to 3 by 5. And I think that's what they have asked. The common ratio of the GP is how much? 3 by 5, right? I hope this is clear to everyone. Common ratio of the GP is how much? 3 by 5. Correct? Okay, let's do the next one. The fourth, seventh, and the last term of a GP are 10, 80, and 2560 respectively. The first term and the number of terms in GP are this. Then, first term and the last term they have asked, right? They have given the fourth term, seventh term, and the last term, right? So, what is T4? T4 is given to be how much? 10. T7 they have given to be how much? 80. And T last, we don't know it is how much. So it is Tn is equal to what? 2560. Right now we don't know it is how much. Right? Okay, so first we'll use this two. So what is T4? T4 is AR cube. AR cube is how much? 10. And T7 is how much? AR6, which is equal to what? 80. If I just divide them, I will get AR to the power 6 divided by AR cube is equal to 80 divided by 10, right? This will cancel, it will become 8. This will cancel, it will become R cube, right? So I can say that r cube is equal to 8, or I can say r is equal to 2, right? I can say r equal to how much? 2. If I have r as 2 and r cube as 8, then what are they saying? We need to also find first term and the number of terms, right? First term and the number of term. First term, so we can find it from here directly, right? First term we can directly find just putting the value of what? R. So if I put it here, what will I get? I will get a into 2 cube is equal to 10, right? So I'll get 8a is equal to 10, or a is equal to what? 5 by 4. Right? A will be equal to what? 5 by 4. And 5 by 4 is there in this option and this option. So obviously these two are wrong. Right? These two are wrong. Now I have A. I just need to find out about what? N, number of terms. For that, I'm going to use this Tn formula. Right? So what will be Tn? A into r to the power n minus 1 is equal to what? 2560. Correct. What is A? I'll plug in the value. So I'll get 5 divided by 4 into R. R is how much? 2. R is how much? 2. 2 to the power n minus 1 is equal to 2560. Correct. From 5, if I divide this, I'll get 512. Right. I'll get 512. And if I multiply it with 4, right. So what I'll get? 2 to the power n minus 1. This is how much? Already it is 2 to the power 9, right? And this is 2 to the power 2. So this will become how much? 2 to the power 11, correct? 2 to the power 11. 9 plus 2 is 11. So can I say from here that n minus 1 equal to 11? So n is equal to what? 12, right? N equal to what? 12. So the answer is what? C, right? It's not D, it is C, correct? So D is also wrong. The correct answer is how much? C. Alright, I hope this is also clear to everyone. Sixth question. Now let's do the next one. If the first and the nth term of a GP are A and B respectively, right? First and the nth term are this, and if P is the product of the first n term, P is the product of the first n terms, then P square is equal to what? Right? Then P square equal to what? Alright, so they have given T1 to be how much? They have given T1 to be A, right? And Tn, this is given to be B, correct? Okay, and they have given, and P is the product of the first n terms. P is the product of the first n terms. So if I multiply T1, T2, T3, so on, Tn, I'll get what? P, right? Then we need to find the value of P square. Okay, so first let's compare these two. What is Tn? Tn will be how much? A into r to the power n minus 1 is equal to B, correct? So can I say r to the power n minus 1 is equal to B by A, right? R to the power n minus 1 is equal to B by A. Okay, this is one relation we have got. Now let's come here. T1, T2, T3, Tn is equal to what? So what is T1? T1 is A. Let's say T2 will be AR, right? This will be AR square. And this will be what? AR to the power n minus 1, right? AR to the power n minus 1. Now, just count how many A's will be there. In each term, factor of A is there, so it will become A to the power n, right? It will become what? A to the power n, right? And if I see R, right? R will become 1 plus 2 plus 3 plus so on till n minus 1, right? N minus 1. This is given to be how much? P. Am I clear? Okay. Now this is an AP, right? This is an AP. We know number of terms n minus 1, right? So if I apply the sum formula, what I will get? A to the power n into r to the power n minus 1 by 2 into 1 plus n minus 1, right? Is equal to what? P. So 1 cancel. Correct. So I will have A to the power n, right, into r to the power n minus 1 to the power n by 2, to the power n by 2. Correct? R to the power n minus 1, n by 2. Okay. So now what I'll do, I will put this value of r to the power n minus 1 in this. right? I will put this value in this. So what I will get? I will get a to the power n, right, into b by a to the power n by 2 is equal to what? P. Correct? Now this will become a to the power n, b to the power n by 2 divided by a to the power n by 2 is equal to p. Now this and this part will cancel. Correct? Now if they want p square. Mind it, they want what? P square. So if I square on both the side, I will get a to the power n, b to the power n is equal to p square. Right? A to the power n, b to the power n is equal to what? P square. So I can say it is ab to the power whole n is equal to p square. Right? ab to the power whole n is equal to what? P square. So answer is what? C. Correct? Answer is what? C. Alright? I hope I am clear with this. A bit lengthy one. Okay, let's do 8th question. What are they saying? Every term of a GP is positive, and also every term in the sum of two preceding terms. It's a very good question. What are they saying? Every term of a GP is positive. So this is a positive GP, correct? And also every term is the sum of two preceding terms, right? So let's consider the GP. If I consider a GP, it will be AR square and so on, right? AR square, so on. So if I consider any term, right? Let's say I consider AR square, right? This will be the sum of two preceding term, right? This will be the sum of two preceding term according to the given information. So can I say that AR square is equal to A plus AR? Right? I can say that AR square is equal to what? A plus AR. Now, A I will take common and it will cancel. So AR square is equal to A into 1 plus R. A and A will cancel. So it will become R square minus R minus 1 equal to 0. Right? R square minus R minus 1 is equal to 0. If this is R, it's a quadratic. So I can find by formula method 1 plus or minus square root of b square minus 4ac upon 2a, right? If you do b square minus 4ac, you will get 5, right? So it is giving us two values. R is equal to 1 minus root 5 by 2, right? And R is equal to 1 plus root 5 by 2. Correct? So which answer will be? This is a negative number. This is negative. So if it is negative, the second term or every alternate term is going to be negative. That is why we reject this one, right? And this is the correct answer, right? 1 plus root 5 by 2. So which option is this? 1 plus root 5 by 2. I think this is the B option, right? Root 5 plus 1 by 2 or 1 plus root 5 by 2. It won't make a difference, right? So this is the correct answer for this. Okay. Next. The sum of first three terms of an increasing GP is 13, right? Sum of first three terms of an increasing GP is what? 13. And the product is 27, right? The sum of the first 5 terms is equal to what? All right. So first 3 terms, which will be A, right? S3. S3 will be what? A plus AR plus AR square. This they have given to be how much? 13. Right? And the product P. P will be what? A into AR into AR square, right? A into AR square is equal to given to be how much? 27, right? If I see this carefully, it is actually what? A into A cube into R cube is equal to 27, right? So I can say it is AR whole cube is equal to 27. It means AR is equal to 3, right? It means AR is equal to 3. So I can write from here that A is equal to 3 by R, right? I can write from here that A is equal to 3 by R. Okay, now if A is 3 by R, I can use it here, right? So it will become 3 by R, right, plus 3 by R into R square, right, is equal to how much? 13. Right, it is equal to how much? 13. So this and this will cancel, you will have 3r plus 3 plus 3r is equal to 13, or I can say 3 by r plus 3r is equal to 10. Right? Now if I take LCM here, what I will get? I will get 3r square minus 10r plus 3 is equal to 0. Right? 3r square minus 10r plus 3 is equal to 0. Now what I'll do, I will just take the LCM. Right? Factorize this. So if I do factorize, I will get 3r square minus 9r minus r plus 3 is equal to 0. Right? So 3r, if I take common, I'll get r minus 3 minus 1, r minus 3 is equal to 0. Right? Okay. So you will have r is equal to 1 by 3 or r is equal to 3. Right? R is equal to 1 by 3 or r equal to 3. If I see r, what are they asking now? They are asking sum of first 5 terms. Okay. So if I have r equal to 3 or r equal to 1 by 3, you can consider any one of this, the answer will not change. Right? So if I consider, let's say r equal to 3. Right? If r is 3, I'll get a to be how much? 1. Correct? If I have a as 1, r as 3, then I can apply the formula of S5. Right? What will be S5? 1 into 1 minus 3 to the power 5 upon 1 minus 3. Right? What is 3 to the power 5? 3 to the power 5 is 243. And 1 minus this is minus 242. So 242 divided by 2. Right? 242 divided by 2. It is going to be how much? 121. Right? It is going to be how much? 121. The correct answer will be how much? 121. I hope this is clear to everyone. Right? We just found out 3r and then we got r and we got a also. Correct? I guess the sum of GPs are a little bit lengthier than AP, and you may have found it difficult also, right? Because it is learning for the first time. Okay. Now this question can also be done in one more way, right? In which you assume the terms to be what? A by r, a and ar. Instead of ar square, what you can assume? You can assume the terms, as you could have assumed the terms to be what? A by r, a and ar, right? Still you have got the same answer. The answer will not change. Only the technique or the way of doing this question will change. Okay. All right. Let's do the next question. The first term of a GP whose second term is 2 and the sum to infinity is 8. Okay. Sum to infinity they have given, right? Second term they have given. The first term is what, right? We need to know the first term. All right. So they have given T2, right? I'll change the color. Okay. So they have given T2 to be how much? 2, right? And sum to infinity to be how much? 8. This is what they have given, right? What is T2? It is AR. AR is what? 2. Okay. And what is sum to infinity? Sum to infinity is how much? S infinity ka formula is A upon 1 minus R is equal to what? 8. Right? From here, I can write A is equal to what? 2 by R. Right? A is equal to 2 by R. I can plug in this value here. So I will get 2 by R into 1 minus R is equal to 8. Right? This and this will cancel, so you will get 4. Correct? So now you will have 1 is equal to 4 R into 1 minus R. Right? 1 is equal to what? 4R into 1 minus R. Right? From here, I think you will get 4R minus 4R square. 4R minus 4R square is equal to 1. Right? If you bring everything on one side, you will get 4R square minus 4R plus 1 equal to 0. Right? 4R square minus 1R plus 1 equal to 0. Okay. Now, this actually is what? 2R minus 1 whole square equal to 0. Right? 2R minus 1 whole square equal to 0. It means that R is equal to 1 by 2. Right? It means that R is equal to what? 1 by 2. If R is 1 by 2, I can plug it by value here and I'll get the value of A. It is how much? 2 into 1 by 2. So I'll get 4. Right? So A, first term is how much? Understood? I hope this is clear to everyone, right? Let's do the next question. 11th. The third term of a GP is 5. The product of its first 5 term is, right? Third term they have given is how much? 5. And the product of its first 5 term is equal to what? Okay, let's see. So they have given T3 to be how much? 5. And product of first 5 term, P5, is given to be how much? We need to find. Okay, so let's see. What is T3? T3 is going to be A into AR square, right? AR square is equal to 5. Okay, this is one information. Now, they have asked what? P5, product of first 5 terms. So it is going to be how much? AR square, AR cube, AR to the power 4, right? This is they have asked. So this, in this, how many A's are there? 5, right? So it will be A to the power 5. And R will be 1 plus 2 plus 3 plus 4 will be what? 10. So it is actually A into R square to the power 5, right? So it means 5 to the power 5, right? So it will be how much? 5 to the power 5 is, I guess, 3125, right? 5 to the power 5 is how much? 3125. So the correct answer for this one is always C. Okay, I guess this is also clear to everyone, right? This question is also clear. Next, 12th. I think this is the last one. After this, there will be worksheet 10. Right? Yes. So 3 distinct numbers, X, Y, and Z form a GP in that order. And the number 7X plus 5Y, 7Y plus 5Z, 7Z plus 5X form an AP. Okay. The common ratio of this GP is equal to what? All right. So what I will say, since these 3 numbers, since these 3 numbers, right? This one, and this one forms an AP. So what I can say, twice of the middle term, which is 7Y plus 5Z, right? Twice of the middle term, right, is equal to 7X plus 5Y, first term, plus third term, which is 7Z plus 5X, right? 7Z plus 5X. Okay. So it is how much? 14Y plus 10Z is equal to 7X plus 5X is 12X, right? And this will be 5Y plus 7Z, right? Now you will bring all this thing to one side, right? So what you will have, I think, 7Z to be on one side, if you bring it here, and Y if you send it that side. What do I get? I will get 10Z minus 7Z will be what? 3Z, right? And 12X is as it is. 12X will be as it is, and this will be what? 5Y minus 14Y will be what? Minus 9Y, right? Minus 9Y, okay. Or I can also say it is what? 3 is equal to 12 X by Z, right? Or minus 9 Y by Z, right? 3 is equal to, and I think it is divisible by 3 also. So if I divide with 3, I will get 1 is equal to 4 X by Z minus 3 Y by Z. Correct? I divided both sides with what? 3. Right? Now I know X, Y, and Z are in GP. Right? X, Y, and Z are in GP. So if X is, if I write it here, if X is equal to A, Y is equal to AR, and Z is equal to AR square. Right? So X by Z will be equal to what? 1 by R square. Right? And Y by Z will be equal to what? 1 by R. Right? So from here what will I get? I will get 1 is equal to 4 by R square minus 3 by R. Right? If we take LCM, I'll get R square plus 3R minus 4 equal to 0. Right? R square minus 3R minus 4 equal to 0. So now you will factorize this. you will have r square plus 4r minus 4 equal to 0, or r plus 4 minus 1 r plus 4 equal to 0. So it means that r equal to 1 or r equal to minus 4, right? R equal to 1 or r equal to minus 4. So r equal to 1 has to be rejected, right? R equal to 1 has to be rejected. Why? Because if r is equal to 1, all the terms will become equal, a, right? But they have said distinct terms, right? If it is distinct, then we have to remove it. So what I will get? I will get r equal to minus 4. So the correct answer is for what this? Option A, right? The correct answer for this is what? Option A. Now we'll be learning about infinite GP. So we'll see 1 or 2 questions of infinite GPs, right? And then we'll be practicing more example based on your worksheet. All right? So let's do infinite GP. Okay? Infinite GP. Give me a minute. Okay, let's do one question of infinite GP. What is the question? The question is saying that there is an equilateral triangle, right? I'll not write the whole question. I'll explain you the question. Right? There is an equilateral triangle. Okay, whose side they have given to be what? 24. So let's say this is A, this is B, this is C, right? And one of the side of this is what? 24 centimeter. Right? How much? 24 centimeter. It's an equilateral triangle. Okay. Now, what they have done? They have joined their midpoints. Right? So let's say this is the midpoint. So they have joined this midpoint, right, of this triangle, right? Then again they have repeated this thing. They have joined the midpoint of this triangle, right? Then again they are doing the same thing. So they are joined and so on, right? So on. And this will continue, right? This will continue. So what we need to do, what they have asked the sum of perimeter of all the triangles, right? What they have asked, I'll write it here. Sum of perimeter of all triangles, right? How many triangles will be formed? It will be formed till infinity, right? The triangles will be what? Till infinity it will be continuing. Okay, now let's do this question, right? So for right now, I'm not assuming that it is 24. Right now I'm assuming that this side length is actually what? A. Right? This side length is what? A. Okay, and they have given that this point is the midpoint. Let's say this point is what? M. This is the midpoint. Can I say this length will be how? A by 2. Right? I can say this length will be what? A by 2. Okay. Now this angle is how much? 60. And this angle will be equal to this angle. So this also will be how much? 60. So it means that this angle, this triangle will also be what? Equilateral triangle, right? If it is equilateral triangle, then I can say that if this is A by 2, then this length will also be what? A by 2, right? I will write it here. Since this length is A by 2, right? This length will also be what? A by 2, right? It means that when I join the midpoint of the given triangle, the triangle formed, right? Its length of the side will be how much? Half of the length of the original triangle, right? Its side length will be how much? Half of the length of the original triangle, right? So what will be the perimeter of first triangle? What will be the perimeter of first triangle? It will be 3A, right? Then second triangle will be what? 3 into side length, which is what? A by 2, because its side length is what? A by 2. Then this for green triangle will be half of white triangle, which will be 3 into half of A by 2, right? And so on. it will continue till where? It will continue till infinity. This process will be continue till what? Infinity. Okay, if this is still infinity, it means it is an infinite GP, correct? It's an infinite GP, and if I find R will be how much? 3a by 2 divided by a, 3a. So I'll get how much? 1 by 2. I'll get how much? 1 by 2. We have R, we also have a first term. So I can find S infinity. S infinity will be how much? A upon 1 minus R, right? In this case, A is how much? 3 into side length, right? What is A? A is given to be what? 24 upon 1 minus half, right? We saw that R is equal to how much? Half, correct? So if I plug in here, what is the value I'll get? 3 into 24 will be how much? 72, and 72 into 2 will be how much? 144, right? So sum of perimeter of all the triangles, right? Sum of perimeter of all the triangle will be how much? 144, right? Sum of perimeter of all the triangle will be what? 144. Now I want you to do the same question. Just you find sum of areas of all triangle, right? Areas of all triangles till infinity, right? Sum of, instead of finding the perimeter, what do you find? Sum of areas of all the triangle. Okay, please do it. I'll give you 2 minutes to solve this. Please do it. Okay, for area, right? We need to find the area. So for area, what I'll do? What is the area of equilateral triangle? Root 3 by 4 into a square, right? The next will be what? Root 3 by 4 into a by 2 square, and so on till infinity, right? So on till infinity, right? So now if I check R will be how much? This divided by this, right? So it will be a by 2 whole square, right, divided by a square, because root 3 by 4 to anyway is common between all of them, right? So what will be R square right now? R square will be how much? 1 by 4, right? R square will be how much? 1 by 4. If R square is 1 by 4, R is 1 by 4, I can say S infinity, right? S infinity will be how much? A, which is root 3 by 4 into a square, which is 24 square, divided by 1 minus 1 by 4, correct? So you can solve this and you can get the value, right? You can solve this, whatever number it comes, you can get the value. It's very simple. Just you have to calculate this, all right? I hope this question is clear with all of you. And with this, we have completed sequence and series also. Now we'll be doing questions based on the worksheet, and then we'll be ending the lecture, right? So let's do questions from worksheet number 10, right? Worksheet number 10. Let me see whether they have they have the next worksheet or not. Okay, I think they have not made it. So let's do it there only. So let's discuss worksheet number 10 in the class. Okay, we have time left, so we'll be discussing worksheet 10, right? Worksheet number 10. Okay, let's do the first question. What is the first question saying? It's on page, if you have the book, please open page number 68, right? Page 68, worksheet number 10. What is the first question saying? They have given a1 is equal to 2 and an plus 1 divided by an is equal to 1 by 3, right? Is equal to 1 by 3. Then what we need to find? Sigma r equal to 1 to 20, right? R equal to what? 1 to 20. So how will I do this question? See, what does this mean? if I have divided n plus 1 term with an, I am getting a fixed constant ratio. It means what? This itself signifies what? It's a GP. And this is what? R. Right? This is what? R. If this is R and this is A1 they have given, right? Then what have they asked us to find? Sum of 20 terms. Because if I expand this, I will get A1, A2, so on till A20. Right? A1, A2, so on till what? A20. So it will be what? Sum of 20 term will be what? A into 1 minus R to the power 20 divided by 1 minus R. Right? 1 minus R. What is A? First term they have given it to be how much? 2. So if I write it here, 2 into 1 minus 1 by 3 to the power n divided by 1 minus 1 by 3. Right? 1 minus 1 by 3. Now what is 1 minus 1 by 3? 1 minus 1 by 3 will be how much? 2 by 3. Right? 1 minus 1 by 3 will be how much? 2 by 3. So I can just divide this. So it will become 3 times of 1 minus 1 to the power 3 to the power n. Correct? So which option it is matching? Achha, n is 20, right? N is given to be how much? 20. So option B. Right? Because n is 20. So you will get 3 into 1 minus 1 upon 3 to the power 20. So the option number is what? B. Understood? I hope it is also clear. In this question, what you have learned, that whenever they given this format, an plus 1 upon an, this actually signifies what? GP. Right? This is signifying what? GP. This is a form of a GP. Understood? Okay. And if they give in this manner, an plus 1 minus an is equal to, let's say, some number k, right? Let's say 3. Then this signifies what? It's a AP, right? This will be what signifying? It's a AP. Understood? Okay. Next question. Second question. I'll read the question. The sum of an infinite geometric progression is 2, right? So they have given S infinity to be 2. Okay. And sum of geometric progression made from the cubes of this infinite series. Made from the cube. So let's say S infinite dash, right? This dash signifying the sum of cube is equal to what? 24. Then find its first term and the common ratio. Right? First term and the common ratio. Okay. So let's see. See, for this normal regular one, what will be the series? AR square, so on till infinity. And this they have given sum to be how much? 2. Right? So what will be the sum of infinite terms? It will be A upon 1 minus R equal to 2. Right? A upon 1 minus R equal to 2. Right? And what about sum of infinite cube? Right? Sum of a series, same series, but cube of them. So this series will be looking like A cube, AR cube, AR square cube, so on, right, till infinity. Correct? Now if you see, for this series, the first term is what? Cube of it, right? The cube of the original term. And R also. R is also how much? R is given to be how much? R will also be R cube. So now this formula will be what? A cube upon 1 minus R cube, right? A cube upon 1 minus R cube is given to be what? 24, right? 24. Now from here, can I say A is equal to 2 into 1 minus R? Right? I can say from here that A is equal to 2 into 1 minus R. If A is this, I can plug in this value here. Right? If it is value, what I can do? I can write 2 cube into 1 minus R whole cube upon 1 minus R cube is equal to 24. This is 8. 8 divided this is what? 3. Right? Now, what is the formula of A cube minus B cube? A cube minus B cube is how much? 1 minus R into 1 plus R square, right? So this 1 minus R and this will also be cancelled. It will become 2, right? This will also be becoming 2. So what now I'll have? I will have 1 minus 2R plus R square divided by 1 plus R square equal to what? 3. right, equal to what? 3. Now I can cross multiply. If I cross multiply, I'll have 1 minus 2r plus r square is equal to 3 plus 3r plus 3r square. Right? Now, I'll bring everything on one side, so I'll have 2r square plus 5r plus 2 is equal to 0. Right? 2r square plus 5r plus 2 is equal to 0. So, it means it is 2r square plus 4r plus r plus 2 is equal to 0. 2r, if I take common, it will become r plus 2 plus 1, r plus 2 is equal to 0. So, I'll have 2r plus 1 and r plus 2 is equal to 0. So, r will be equal to minus half or r will be equal to minus 2. Right? Now, out of this, minus 2 has to be rejected. Right? Minus 2 has to be what? Rejected. Why it has to be rejected? Can anybody think why it has to be rejected? Because I told you that S infinity formula is only valid for r between minus 1 to 1. Right? It is only valid for between minus 1 to 1. Right? So, in this case, r is minus 2. This r is not between minus 1 to 1. That's why it is rejected. So, r is how much? Minus half. Right? If r is minus half, you can plug this value here, right, in this one, and you will get a to be how much? 2 into 3 by 2, which means a will be 3. Right? In this, you will get a to be how much? 3. Okay? I hope this is clear for everyone. This is the second question. A little bit manipulation is required now. Right? Third question. Right? Third, what they are saying, how many numbers lie between 10 and 300, which when divided with 4 leaves remainder 3, which when divided with 4 leaves remainder 3, right? So the first number will be 11, right? First number will be what? 11. Why? Because, why is this? Because 11, when I divide with 4, right, I'll get remainder as 3, and it is lying between 10 and 300, right? 300. Okay. Right. Now 300 is perfectly divisible of what? 4. So the last number in this case will be what? 29. This is not a question of GP, it's a question of AP, right? But I think it's a mixed question of AP and GP. So we'll do from there. What they are saying, if the first term is 11 and next term is 299, and the other terms will be what? 15, 19 and so on, right? Then what will be the sum, right? No, we need to find number of terms, and we need to find. So we already have Tn, right? Tn will be equal to what? A plus n minus 1 into d, correct? What is Tn? Tn is 299 is equal to A is how much? 11 plus n minus 1 into d. D is how much? 4, correct? So 299 minus 11 will be how much? 288, right? And 288 is equal to what? 4 into n minus 1. So I can say 288 divided by 4 is equal to n minus 1. I will have 72, right? So 72 is equal to n minus 1. So I can say n is equal to how much? 73. Right? N will be equal to how much? 73, which is in this case option B. This was pretty simple question. Just you need to guess, you need to find the right terms, right? Which is 11 and 299. Correct? Because between 10 to 300, these are the two terms will be starting and the ending. Okay, I hope this is clear to everyone. Right? Fourth question. If x, 2y, 3z are in AP, they have given x, 2y and 3z are in what? AP. Whether distinct x, y, z are in GP, right? X, y, z are in what? GP. Okay. Then what they are saying? Find the common ratio of this GP, right? Find the common ratio of this GP. So what I will do here, if these are in AP, right? These are in AP, can I say 4y, right? Twice of, or if I want to write 2 into 2y is equal to what? X plus 3z, right? X plus 3z. Now it means what? 4y. 4y is equal to x plus 3z, correct? Now let's say if I divide this whole equation with what? If I divide this whole equation with what? X, right? If I divide the whole equation with what? X. So what will I get? I will get 4y by x plus equal to x plus 3z by x, which will be 1 plus 3z by x, right? 1 plus 3z by x. All right. Now, see, if they are in GP, right? So I can say y by x will be equal to r, and z by x will be equal to what? R square. Right? It will be equal to what? R square. I can plug in these values here, right? So if I plug in, what will I get? I'll get 4r is equal to 4r is equal to 1 plus 3 r square. So I will get 3r square minus 4r plus 1 equal to 0, right? 3r square minus 4r plus 1 equal to 0. It means that 3r square minus 3r minus r plus 1 equal to 0, right? So 3r common, r minus 1 minus 1, r minus 1 equal to 0, right? So you will have r equal to 1 by 3 and r equal to 1, right? Again, as I have said before also in one of the previous question, that r cannot be equal to 1, right? R cannot be equal to 1. Why? Because if r becomes 1, all the terms will become identical, but they have mentioned in the question they are distinct. If it is distinct, then the common ratio should be how much? 1 by 3, right? The correct answer for the common ratio is how much? 1 by 3, which is option C, right? Which is option C, right? I hope this is clear to everyone. Let's do the next one. The third term of a GP is the square of the first term, right? Third term of a GP. Third term means A, AR and AR square. What are they saying? The third term is the square of the first term. So AR square, that is they have given T3 is equal to T1 square. So AR square will be equal to what? A square, right? AR square will be equal to what? A square. So I can cancel and this will become R square will become what? A. Right, R square will become what? A. And the next thing what they have heard? If the second term is 8, second term is how much? 8. So second term, T2 they have given 8. What is T2? It is AR. It is given to be 8. I will plug in the value of from here, right? So I will get R square into R is equal to 8 or R cube equal to 8, right? If R cube is 8, I can say R equal to 2, right? R cube is, R will be equal to what? 2. If R is 2, I can put it here and I'll get A to be how much? 4. Right? I can get A to be how much? 4. So the answer for this is, what they are asking? Find its sixth term, right? Now I have A to be, R also we have also A also, so I can find the sixth term. Sixth term will be how much? A into R to the power 5, right? Which will be 4 into 2 to the power 5, which is 2 to the power 7, right? And that will be how much? 128, right? 128. So option B, right? The correct option is what? Option B. This was which question? This was question number 5. Then we will do the next one. Question 6. A GP consists of two n terms if the sum of terms occupying the odd places is S1, right? S odd is equal to what? S1, right? And that of even places, S of even places is what? S2. Then find the common ratio of this progression. Common ratio we need to find out in terms of S1 and S2. Okay, so let's say A, AR, AR square, right, and AR cube, so on, till the last term is what? AR to the power 2n minus 1. Right, what they have given, AR to the power, last term is 2n terms are there, so it is AR to the power 2n minus 1. Okay. Now, if the total number of terms, right, total number of terms in this is given to be 2n, right, if it is given to be 2n, it's going to be 2n, so can I say half of them, n will be equal to odd, n number of terms will be odd, and half of them, n will be equal to even, right? Half of them will be odd, half of them will be even. For example, let's say there are 10 terms, right? So 5 odd terms will be there and 5 even terms will be there. Both will be what? Equal. No one will be one extra. Correct. Now what they are saying? So S odd, odd means this one, right? The common ratio is R square. For both, it will be R square. So S1 will be equal to what? A into 1 minus R square to the power n divided by 1 minus R square, right? S1 will be this, right? And S2 will be how much? For even terms, it will be AR into 1 minus R square to the power n divided by 1 minus R square. Correct. Now, if you see, if I just divide these two, right, everything will cancel out. Only what I'll get S2 upon S1 will be equal to what? R. Right? S2 upon S1 will be equal to what? R. And I think that is what they have asked. The common ratio, right? Common ratio will be how much? S2 upon S1 equal to R. So the correct option is what? Option number B. Right? Correct option is option number B. Okay. So this was the 6th one. Let's do the 7th one. Today we'll finish the worksheet 10 and then I'll leave you, right? Then will be worksheet 11, which is the last worksheet on sequence series. That will be homework. We'll discuss it next time. So 7th, what they are saying, find the sum of first 7 numbers which are multiple of 2 as well as of 9, right? 2 as well as of 9, right? Any number which is a multiple of 2 and 9 will be, they have given the hint also, it is starting from 18, right? So it is 18, and the next number will be how much? 36, right? We're just going to add. Okay. Now we know for this particular sequence, right, the next number will be 54, right? It's a multiple of what? 18. Okay. Now for this sequence, we know the first term, right? And we also know the common difference, and we know the number of terms. The number of terms they are asking is how much? 7 terms, right? So S7 we need to find. S7 will be what? 7 by 2 into 2A plus 7 minus 1 into D will also be what? 18. Correct? So you can calculate this and you will get the answer. Okay, this calculation part I have left for you people. You can do this. Alright, this one is very simple. Just you have to calculate. 2 into A plus n minus 1D. Okay? Alright. Next. 8th, what they are saying, find A plus B plus C such that following numbers are in AP, right? Following numbers are in AP. So they have given A 7, B 23 and C. Correct? Following numbers are in AP. We need to find the sum of A plus B plus C, right? Now see, okay, I can say from here that, okay, this is A, first term, this is second term, this is third term, this is fourth term, and this is fifth term, correct? So what is T2? T2 will be what? A plus D, this will be 7. And this is T4 is given to be what? A plus 3D, this is given to be how much? 23, right? If I subtract them, I'll get 2D is equal to 23 minus 7, right? Which is equal to 16. So I will get D is equal to what? 8. 16 by 2. So D will be equal to what? 8. If D is 8, right? So I can get from here A also. A will be equal to what? Minus 1, right? A will be equal to minus 1. If A is minus 1, and D is 8, I can get B. What is B? B will be equal to A plus 2D, right, which is minus 1 plus 2 into 8, which will be how much? 15, right, which will be how much? 15. And then last C, C will be what? A plus 4D, it is the fifth term, correct? So that will be minus 1 plus 4 into 8, right? So minus 1 plus 32, which is going to be 31. Right? It is going to be what? 31. Now we have all the terms, we can just add them. So 31 minus 1 will be 30. 30 plus 15 is going to be 45. So A plus B plus C is equal to what? 45. Right? And that is there in the option C. Right? It will be there in option C. Okay. Let's do the next one. Ninth question. Ninth one, they are saying if 4m plus 8, 2m square plus 3m plus 6 and 3m square plus 4m plus 4 are three consecutive terms of an AP, right? They are three consecutive terms of an AP. I have told you that if A, B, C are in AP, right, then what can I say? 2B will be equal to A plus C, right? I can say 2B will be equal to what? A plus C, right? So similarly in this question, they have given that 4m plus 8, comma 2m square plus 3m plus 6, comma 3m square plus 4m plus 4. Right? These three terms are in what? AP. So I can write 2 into 2m square plus 3m plus 6 is equal to 4m plus 8 plus 3m square plus 4m plus 4, right? So from here what will I get? I'll get 4m square plus 6m plus 12 is equal to 4m plus 4m is 8m, right? And from here 3m square, 8 plus 4 is 12, right? Now if I bring everything on one side, I'll have m square minus 2m, 12 and 12 will cancel. It will be 0, right? So it means m is equal to 0 or m is equal to what? 2, right? M is equal to 0 or m equal to 2. But I think so they have given both the answer. So m equal to 0 and m equal to 2. So it's option number A, right? It is on the option number A, right? Okay. Then the last question, 10th. 10th, what they are saying? 2's AP have the same common difference. Okay, there are two APs which have the same common difference. The first term of one of this is minus 1 and that of the other is what? Minus 8. Then the difference between their fourth term, right? Difference between their fourth term. They have the same common difference. So see, let's say AP1, right? What is AP1? The first term is how much? Minus 1, right? And the common difference is same. So minus 1 plus D, minus 1 plus 2D, and minus 1 plus 3D. Right? And the other AP, this is AP1, this is AP2. It will be how much? Minus 8. So minus 8 plus D, minus 8 plus 3D, and minus 2D. Minus 8 plus 3D. Correct? Now what they are saying? Difference between their fourth term. So if I subtract minus 8 plus 3D with minus 1 plus 3D, right, what will I get? 3D will cancel. I'll have minus 8 plus 1, which is how much? Minus 7, right, which is there. It's there in the option, but it is there in 7 only, right? So the answer, I think it will be 7, right? Because I think they have subtracted this from this, AP1 from AP2. Okay, that is why, that's how you'll get 7. Okay, so we have compared worksheet number 10. Now I'll give you today's homework. Today's homework is worksheet 11. Worksheet 11, page number 69, right? Page number 69, all 30 and I think, yes, all 13 questions. Right? It will be a mixture of both AP and GP. So today we have completed sequence and series also. Okay. So 3 chapters are completed so far in CBC 2. First one was number system, second was quadratic equation, and third was sequence and series. Now the last chapter, I think sets is remaining. So we'll be doing sets from Monday. All right. This is the homework for today. If you guys have any doubt, today we didn't do any theory, just we did questions on infinite GP. If you guys have any doubt, you can go to the nearby centers, right? And there will be doubt faculties there available from 2 to 5 o'clock. Okay, I am just reminding once again, if anybody have any doubt or any question you have missed or not understood, then you can please visit the center and there you can discuss a doubt with the doubt faculty. All right, thank you everyone. See you on Monday.